Determine whether the sequence is arithmetic. If yes, identify the common difference and give the next three terms. In order to identify whether a sequence is arithmetic or not, you need to take the difference between the first and second, and then again between the second and third, just to confirm that the difference, in fact, is the same. So typically how I do that is I would do negative 12 minus a minus 3. So that's going to be negative 12 plus 3. So that's going to be a negative 9. And then if I do negative 48 minus a minus 12, that's going to be a negative 48 plus 12, which is going to equal negative 36. So in fact, this is not arithmetic. So the answer would be no. For number 3, the difference between 4 and 11 is 7. And the difference between 11 and 18 is 7. So this is arithmetic. And the difference is 7. And then we're supposed to, if it's yes, we're supposed to give the next three terms as well. So we would add 7 to 25 and get 32. Add 7 to 32 and get 39. Add 7 to 39 and get 46. The difference between negative 9 and negative 33 is negative 24. And the difference between negative 33 and negative 57 is negative 24. So this, in fact, is an arithmetic sequence with the difference being negative 24. So to find the next three terms, we would add negative 24 to negative 81 for the next term. So that's going to be negative 105. And then we'll add negative 24 to 105 and get negative 129. And then add negative 24 to negative 129, and we would get negative 153. Number 6, for the fraction one, to find the difference, you would do 5/6 minus 1/2, which you have to get a common denominator. So 5/6 minus 3/6, that's going to be 2/6 or 1/3. So now we'll see 7/6 minus 5/6 equals 2/6, which is 1/3. So in fact, this is arithmetic. So the answer is yes. And the common difference is 1/3. So in order to get the next three terms, you would add 1/3 to 3/2. So you would get a common denominator. 2 goes into 6 3 times, and 3 times 3 is 9. 3 goes into 6 2 times, and 2 times 1 is 2. So that's going to be 11/6. And instead of, I'm going to add 1/3, but I know I'm going to have a common denominator. So here I'm just going to go ahead and add 2/6 again. And that's going to give me 13/6. And I'll add 2/6 again, which would give me 15/6, which reduces to 5/3. Or 5/2, sorry. So the next three terms would be 11 sixths, 13 sixths, and 5 halves. Write a rule for each sequence, and then find the indicated term. So what you're going to do on this one is we know that A1 is 12. And then you have to find the common difference. So the common difference, 12 from 27 is 15. And just to confirm that this is in fact arithmetic, but it should be, if I added 15 to 27, it would be 42. So the common difference is D equals 15. Now the arithmetic sequence formula is A sub n, and then the formula is D and then n minus 1 plus A1. So let's just substitute in what we know. We don't know this. We do know the common difference. We don't know n minus 1 necessarily. But we do know A1 is 12. So now to simplify, we'll distribute the 15 throughout the parentheses. And so and then you combine like terms. So it's 15n minus 3. That's the rule. And then in order to find A sub 18, what we would do is write A sub 18 equals 15 times 18 minus 3. And that equals 267. Because 15 times 18 is 270. Okay, number 9. You know that the first term is negative 40. And you can see that the difference is adding a negative 4 or going down by 4 each way. So we'll just substitute. I'm not going to rewrite the formula. I'm just going to go ahead and use the one that I wrote up there because I don't have a lot of room in these boxes. But so we'll write A sub n equals, and then the common difference is negative 4 times n minus 1 plus negative 40. So I'm going to distribute the negative 4 throughout the parenthesis. Negative 4 times a negative 1 is plus 4 minus 40. So it's A sub n negative 4n minus 36. So that's the rule for this sequence. And then we'll plug in to find the 49th term. We'll plug in 49 in for n. And then negative 4 times 49 is negative 196 minus 36 is negative 232. All right. Karen's New Year's resolution is to work out each day on her elliptical. The number of calories she has burned each day since she started is shown below. Write a rule for the sequence and find the number of calories that Karen will burn on the 30th day. So it's going up by 8, 349 to 357. The difference is 8. And 357 to 365 is 8. And the first term is 349. And the common difference is 8. So using the same formula that we've had, we're going to come up with the rule by plugging in the common difference times n minus 1 plus the value of a sub 1. And now we'll distribute the 8 throughout the parenthesis. So our rule is 8n plus 341. Now, to figure out where she'll be on day 30, you'll plug in 30 for n. And we find that Karen will be burning 581 calories on the 30th day. This is the rule. Okay. For number 12, if you're given the terms, if the given terms are part of an arithmetic sequence, write a rule for the sequence and then find a sub 9 or the 9th term. So what we'll do to do this is actually plug in the 5th term value. Okay. And then we don't know what the distance is, what the common difference is. I mean, but we do know 5 minus 1. That's the distance between this term and this term. And we do know the value of the first term. So we can plug in certain things that we know. Because if you look at the formula, it's a sub n equals the common difference times n minus 1, which would be the whatever term that you're looking for minus the one before it, plus 11. So we plugged in a sub n, or the value of a sub n, which is 27. And then we we don't know what the common difference is, but we know that it's the 5th term. So this is where that n minus 1 is, right here. N minus 1 plus 11. So now we'll figure out what the common difference is. So you've got 5 minus 1 times d. So that's going to be 4d plus 11. And then you're going to subtract 11 from both sides. And now you have 36 equals 4d divided by 4. And d equals 9. So now to find the 9th term, you would plug in the common difference, which we found, which is 9, did something wrong. Because I can't subtract. Lord help Miss Sparks. I couldn't subtract yesterday either. It's a theme. No, I couldn't add yesterday. It's still a theme. So D equals 4. So now we have 4, which is the common difference. Hold on just a minute. I skipped a step. Got to find the rule first. So we can take A sub n times 4 times n minus 1 minus 11. It's really hard doing this when I'm not talking to anybody. I don't know why, but it is. 4n plus 7. And then now we'll actually plug in the 9. Perhaps the next one will go more smoothly. And then 36 plus 7. So the 9th term is 43. All right. So we'll plug in negative 23 equals D. And then this time we're going to have 14 minus 1 because that's the distance between this term and this term. And then plus 3. Negative 23 equals 13D plus 3. So we'll subtract 3 from both sides. Let's see if I can add and subtract a little better this time. So negative 26 equals 13D. Divide both sides by 13. It's negative 2 equals D. So now we have the common difference. And so we'll find our rule. A sub n equals negative 2 times n minus 1 plus 3. So negative 2n plus 2 plus 3. Because negative 2 times a negative 1 is positive 2. So we have negative 2n plus 5. So that's our rule for number 13. So to plug in, to find A9 for this one, we'll plug in negative 2 times 9 plus 5. So this will be negative 18 plus 5. And negative 18 plus 5 is negative 13. So the value of the 9th term in that sequence is negative 13. And since number 15, and since I kind of messed up number 12, I'm going to do number 15, A, because it's a fraction, and I feel like I should do at least one more of these with you guys since I kind of messed up on number 12. So we're going to find we're going to find the common difference, and then we're going to write a rule, and then we'll find a sub 9 in that order. So we've got 6 equals D times, and then 23 minus 1 is in the parentheses. That's the n minus 1 part, plus 1/2, because that's where you add the value of the first term. So 6 equals 23, no, my bad, 22D, because 23 minus 1 is 22D, plus 1/2. We're going to subtract a half from both sides. So you could do 5.5 if you wanted to here, if you'd rather work with decimals. And that would be, or you could do 11 over 2, whichever way you wanted to do that. And then you've got, it's 5.5 equals 22D, and you divide both sides by 22, and you get 0.25D, or if you would have kept it as a fraction, obviously you would have gotten 1/4. Now we're going to find a rule. We're going to plug in 0.25 as our common difference. And we've got n minus 1 plus 1/2. Or probably best to go ahead and write that 1/2 as a 0.5, really. And then we've got 0.25n minus 0.25 plus 0.5. So we got 0.25n plus 0.25. And now we'll plug in a sub n, 0.25 times 9 plus 0.25. So if I have 9 quarters, I have $2.25. And if I add another quarter to it, I've got $2.50. So that's kind of how I did that, because 0.25 just always reminds me of a quarter. Easier way to do it, I think. All right, find the indicated sum for each arithmetic series. So what you're going to want to do is remember that the summation formula basically states that you've got to have the value of the first term and the value of the last term as part of the formula. So we know what the value of the first one is. And let me just go ahead and write that formula out just to remind us of what that formula is for you guys. It's S sub n equals, and then n, which is the number of terms in the sequence or the series. And then you've got the value of a sub 1 plus the value of the last term, all divided by 2. Okay, so that's kind of what we're working with right now to get toward, because we've got the value of the first one, but we don't have the value of this one. And in order to get that, we need to write the rule for this sequence. So the first thing that we're going to do is we can see that it's going up by 2. So we've got a common difference. So actually, we can just find the value by plugging in that common difference like we did on the ones prior to that and just get the value of this 21st term. Much easier than writing the rule first, actually. So 2 times 20 is 40, plus 4 is 44. So now we have that last value that we needed. So the n is the number in the sequence, which is 21, the number of terms in the series. And then the first value is 4. And then the value of S21 is 44, like we just found. And that's all divided by 2. So 4 plus 4 is 48. Divided by 2 is 24. So we've 21 times 24. And that equals 504. Okay, number 18. So A sub n, we see that the common difference, 15 to 4 is a subtracting 11. And, oh no. And if we subtract 11 again, we get negative 7. So our common difference is negative 11. And we're looking for the value of the 12th term. So we have negative 11 times 11 plus 15. So that's going to be negative 121 plus 15. So that's negative 106. So that's the value of the 12th term. So now we'll plug into our summation formula. So it's 12 terms. And our first term value is 15. Our second term value is 106. That's all divided by 2. And we've got 15 minus 106. So that's negative 91. Divided by 2, which is negative, I'm running out of room, negative 45.5. And if I multiply, and that's a negative, if I multiply that by 12, I get negative 546 for that one. And number 20, I'm seeing that I'm starting at, and I'm doing that because notice this one starts with 1 and this one starts with 25. Maybe I should start with that one, actually. I'll do that. You plug in the value 1 into here, A1. 1, so 5 times 1 is 5, plus 1 is 6. So A1 is worth 6. And then 25 plugged in, A25 plugged in. 5 times 25 is 125, plus 1 more is 126. So now I'll plug this into the summation formula. And I got 25 total terms, so that's my n. And then 6 plus 126 all over 2. So 6 plus 126 is 132 divided by 2 is 66. And 25 times 66 is 1,650. So that's the answer for that one. Now you'll notice on number 20, it starts at 9. So you need to find the value at 9. So let's see. A sub 9. 17 minus 6 times 9. 17 minus 54 is negative 37. And then 14 is 17 minus 6 times 14. So that's negative 67. Okay, so the summation, and what you want to do here is it's 14 minus 9 is a difference of 5. Plus 1. So it's 6 total terms. Actually, I wouldn't write it like that either. I would just say that it equals nice sigma, Miss Sparks. Because you have 6 total terms, because you get that from taking the top number, subtracting the bottom number, and then adding 1. Okay, so the first term in the series was negative 37 minus 67 divided by 2 That's negative 104 divided by 2. So that's negative 52. And negative 52 times 6 is negative 312.